Today we're going to introduce parabolas and use transformations to graph the quadratic equations. The quadratic equation or function can come in two forms: in standard form, where it's an ax squared plus bx plus c, or in vertex form, where you have the a on the outside, parentheses x minus h squared plus k. Today we're mainly going to focus on the vertex form. Now the graph of a quadratic is a parabola, basically a U-shaped graph with arrowheads on the ends, meaning it's going to go on forever. Now the parabola can be positive or negative. The difference here is the a value, the number in the very front. If the a value is positive, your parabola holds your soup. If the a value is negative, the parabola dumps your soup. Now think about it. It's a very negative thing if you spill all your soup. The bowl is literally upside down. That's how you know it's a negative a, because it's very negative to spill your soup. However, it's positive if your bowl is right side up holding your cereal. Zeros are the x value that makes the equation equal to 0. Our x-intercepts, or our roots, are going to be at -2, 0 and 6, 0. Normally when we're solving a quadratic equation, those are the points that we're looking for, the zeros. Today we're just going to call them the x-intercepts, or the roots, when we're graphing. Some more key components: the vertex. The vertex is one of the most important parts here. The vertex is literally the center of your graph. Now the vertex is going to contain the minimum or the maximum y value. Notice here that it's the lowest or the minimum, and notice over on the right that that is the maximum or the highest. So the minimum value is the least possible y value. You only have a minimum value when you have a positive a. Meanwhile, the maximum value is the greatest, and you're only going to have a maximum value with a negative a. So you can see there highlighted in blue, that's a negative graph because it's pointing down, but you have a maximum value. The line of symmetry is the line that goes directly through the middle of your graph. What that does is it creates a mirror image. Now if this was drawn perfectly on a computer, then you would see that the distance from the line of symmetry to the right and the distance to the left are the exact same. No matter where you are on the graph, it's always going to be the exact same. It's a mirror image. The axis of symmetry goes directly through the vertex. Let's do a few practice problems. Whenever you're solving these, you first want to find the vertex. The vertex on this one is simply 5, 1. We went to the right 5 and up 1, 5, 1. Does this have a minimum or a maximum value? Well, you can see that it goes low, but it's going to keep going up forever. So that's a minimum value. The minimum value is always going to be your y value. So my y value of the vertex is 1. So we just say y is equal to 1. The line of symmetry is a line. It's a vertical line, which means that the formula for a vertical line is x equals a number. So just look at the x value of your vertex. X equals 5. Here, they want to know the zeros. Well, it never crosses your x-axis, so there are none. Looking at the equation on the right, the vertex is 5, 4. You can see that this has a maximum value. It's never going to go higher than that 4, so it has a maximum value at y is equal to 4. The line of symmetry, remember, it's a line, so you're always going to have an x equals the number, and here the x value is 5 again. Then zeros. So look for where it crosses. It crosses at 3 and it crosses at 7. So you would say 3, 0 and 7, 0. Alright, finally the domain and range. They should sound vaguely familiar. Domain are all possible x values, and the range are all possible y values. When doing this, always find the vertex first. The vertex here is given to us at 5, 3. That means we're going to have a minimum value at y is equal to 3. Now we can find the domain and range. Domain for parabolas are really, really easy. The domain will always be all real numbers. The domain will always be all real numbers because the graph will keep going on and on forever. Remember, this graph is going and going and going in both directions, which means in the x value, it keeps going to the right and it keeps going to the left. So your domain is all real numbers. In set notation, we would write it from negative infinity to positive infinity. You should be familiar with both ways of writing this. Now the range is only starting at a certain point and then going up. So your range is starting down here at 3 where your vertex is, but the graph is going up forever and ever. It's never going to stop. So your range is y is going to be greater than or equal to, because we're including that point, 3. In set notation, you would have a bracket starting at 3 going to infinity. And then you close in parentheses. Remember, you can contain a 3, it's or equal to, but you can never be equal to infinity, and that's why we use the parentheses. Alright, some more vocabulary. A transformation is simply a change in your graph. A translation is a slide, meaning we're not changing the shape, but we're simply moving it left, right, up, and down. A parabola is the graph of x squared. The vertex is the highest or lowest point. Remember, vertex is always a point. The formula that we're going to be working with today is vertex form. Now, how to translate these parabolas. This information is going to be true of almost all of our graphs, so it's very important that you understand it, learn it, and commit it to memory. Inside versus outside. When you have a number inside, so we're talking about this minus h right there, then you're always going to go in the opposite direction in the x value. Think of it this way. This number, the negative 3 right here, is inside the house with the x. Because he's inside the house with the x, he's only going to be talking to the x. Now, because he's stuck inside, he's like a rebellious teenager. I call them the rebellious numbers. They're going to do the opposite of whatever you tell them. So right here it says x minus 3. What that means is that your new graph is going to move to the right 3. He's rebellious. He's told to go left, but instead, when you graph him, he goes right. Now the number on the outside, in this case will be the k, does whatever he wants. He's already outside. He's already in college. He's on his own doing whatever he wants. So he's going to move in the y direction, the same direction he says he's going. So if this says plus 5, that means we're going to move up 5 because he gets to do whatever he wants. Now, because he's outside the house, he's going to be moving in the y direction. Now, we already know that the a value reflects or switches it from positive and negative up or down. Now, if the a value is really small, like less than 1, it makes the graph grow fatter. Basically, it's growing more slowly. So if you have something, but if the x is greater than 1, then it makes the graph grow skinnier. Think of plants. If your plant is growing really slowly, it probably means it's going to have a nice, thick stalk. But if your plant grows really fast like a weed, it's probably going to be really thin and fall over easily. Well, the same thing is going on here. If the graph grows more slowly, it's because it has a fraction in front, and it's going to grow wider. So the graph is going to be wider. If it's growing really fast, meaning it has a large multiplier or a value, then it's actually going to be narrowed because it's growing faster. And we'll go over a couple examples to make that clear. All right, here's a few examples. We're going to start with the very base function, f of x equals x squared. Now think, we don't have any adding or subtracting on this. So that means our vertex is going to be right there at 0, 0. It hasn't changed. Now we need to draw the parabola. Now normally you shouldn't do a data table, but for the first one, we're going to go and do a data table in order for you to see what's happening. If I say f of 0 is 0 squared equals 0, that's where we started at 0, 0. Now what if I put a 1 there? Squared is 1. So that means if I move to the right 1, I'm going to move up 1. Kind of like slope, right 1, up 1. Now if I put a 2, 2 squared is 4. So if I move to the right 1, 2, that means I'm going to have to move up all the way to 4. So put a dot there. Now if I want to do one more, we don't need the data table. I can do it in my head. 3 squared is 9, and so that's going to be slightly off my graph. Remember, whenever graphing these, we have a mirror image. What I do to the right, I do to the left. Now I have my basic parabola shape, and I know it's correct because we just did the math. It's going to look like this. Parabolas are never V's. It should be U shape at the bottom, and then it's going to keep going up, and we know that's supposed to cross at 9. That is your basic parabola shape. Now, what if I put that multiplier in front? I have an a term of 2. Well, I just told you that's going to make it grow more quickly. Nothing's changing with the vertex. There's no adding or subtracting. It's 0, 0. So if I have f of 1, that's going to equal 2 times 1 squared, which is 2 times 1, which is equal to 2. See how it was only supposed to go to the right 1 and up 1, but I have a multiplier, so it went up 2. Because the plant is growing more quickly, it's going to be thinner. So now I have, if I move to the right 2, it's supposed to go up 4, but it's not. It's going up 2 times 4, which is 8. So I was only supposed to go over 2 up 4, but it got multiplied by 2. So it goes all the way up to 8, which is at the very top of our graph. So see how this graph is growing much thinner or narrower because it's growing faster. So compare the blue with the green graph. Your blue is your normal, and the green got multiplied by 2. So it's growing faster, which means it's going to be narrower. All right, now let's actually do some transformations. The pink one here says x minus 3. Well, remember your rebellious numbers. He's inside the house, so he's told to go to the left 3, but instead he goes positive. So if I'm starting at our base 0, 0, he's going to go to right 3, and then the plus 2 is doing what he wants, so he's going to go up 2. Right there. Now there's no multiplier in front, so I know that 1 squared is 1, so I go right 1, up 1. I know that 2 squared is 4, so I go right 1, 2, and I go up 1, 2, 3, 4. And remember, whatever you do to one side, you do to the other. So it should look something like that. Now we'll do one more on the right. It says negative 1/2 in front, and we'll cover that in a second. This says plus 3. Well, it's rebellious because it's inside the house, so we're going to go left 3, and then it says plus 8 on the outside. So we do what he says. Go up 8. And put a dot right there at the top of your graph. Now it's negative. Because it's negative, I know that my graph is going to be pointing down, and it says 1/2. So normally I'd move over 1, down 1. In this case, I'm going to move over 1, down half. Then normally I'd move over 2. 2 squared is 4, so I should go down 4. But no, I'm being multiplied by half. So I go to the right 2, and then half of 4 is only 2. So I go down 1, 2. Then normally I'd go over 1, 2, 3. 3 squared is 9, so I should go down 9, but I'm not. I'm going half of 9. And then normally I would go over 1, 2, 3, 4. 4 squared is 16, but now I'm only going half of 16. Remember, whatever you do on one side, you do on the other, and then we can draw our graph. So if you notice, this graph is wider than the original blue one, simply because we have a 1/2 on the front. It's pointing down because there's a negative sign in the front. All right, now the best way to play with this is to go over and over again. So what I have for you is a activity. Go to this link, goo.gl/BK, lowercase pj, capital P, lower s, and already on there is a graph of a parabola with sliders. Then what you should do is start playing and changing those sliders. See how changing that a value makes it wider and narrower. See how changing the h value inside goes the opposite direction that you tell it, and see how the k moves it up and down. So it should look something like this. We're on Desmos, and if you change the a value to 1, the h value to 0, and the k value also to 0, we have our base graph right here. Now the base graph was already written for you. Now if you start changing the numbers. I want to see what happens when the a value gets big. So as I move the slider to see the a value get larger, I can see that the graph gets narrower and narrower. And this is because, like I said, it's growing faster. So now instead of moving over 1, up 1, it's actually moving over 1, up 5.4. So over 1, up 5.4 off our graph. And that's what's making it really narrow. Now, if we bring that to the negatives, to a fraction less than 1, you can see it's going to get wider. Now we're in the fractions, 0.4, 0.2. So now that it's a very small number, less than 1, then instead of moving over 1, up 1, it's moving over 1, up a little fraction. Now, if we take it all the way to the negative sign, our graph is sad. The negative a is upside down. It's spilling water. And that's what we're getting here, negative a. So we have our blue basic graph that's always going to be the same, and then our red one that we're changing. So let's bring it back to positive 1, and we can start moving the other values. H value moves it left and right. Now the reason why it's moving in the same direction is because they're already taking into account that there's a negative sign in our base equation. So if I have negative 1.5, I move to the right 1.5. If I move my slider to the left, now what it's reading it as a negative, -1. Well, two negatives make a positive, and that's why the graph is moving left and right according to your slider. Now the k value is going to move it up and down. The number on the outside moves it up and down. The best way to do this is to take a couple minutes and play with it and see how the different numbers will change it. Then go back to your original instructions and take notes on what you saw. The last two things I want you to do is first put a number in front of the x, see what that looks like. We haven't done that yet because we don't see it as often, but if I was to go here and put a number in the very front, what does that look like? And add a restriction at the end. What does a restriction do? Well, a restriction simply cuts off your graph at a certain point. So here I have only the graph from greater than -1. Well, if I move my graph to the left, I'm going to get less and less graph. If I move my graph to the right, I'm going to get more and more because that restriction cut it off right there. Now these are a little more advanced settings, and when if you do a Desmos marble slide, you'll need the restrictions. But for now, just make sure you understand what a restriction does and what it looks like without. But for now, just make sure you know the basic functions, moving left, right, making it wider and narrower, making it positive and negative.